right here, we will decide how do we classify R and S for chiral center. In this molecule here, you notice that there are several chiral centers. You can identify that there's one here, another one there, another one here. So in total, there are 3 chiral centers. But what is the absolute configuration using the R and S denotation? Remember, these actually come from the CIP rule, the Cahn, Ingold, and Prelog rule, right? Which means we have to assign the priorities around each of the groups around the chiral center. Let's take a look. 3 bonds being shown, so the last one automatically must be hydrogen. And because this bond here says it points at you, and the other bonds are on the same plane, so the last bond must be pointing to the back. Hydrogen has the lowest priority around all these, is number 4, which is of the highest priority here. So again, 2 fingers up, atom by atom, carbon, carbon, carbon. So for the first junction, you can't decide because it's all the same carbon. So this carbon here at the top connects to a hydrogen. Hydrogen, hydrogen. This carbon below here connects to hydrogen, bromine, and carbon. See, hydrogen, bromine, carbon. This carbon here connects to carbon twice because it's the double bond. So carbon, carbon, and the other side, carbon. Now, we lay out all these 3 atoms that the next carbon is connected to, and then we see. The game is very simple. We always throw in the best card, that means the largest one. Here, there's no choice. I'm putting H. H is the one that's coming from here. Here, again, no choice. It's a carbon. And for this case, we have 3 different elements. Which is the biggest? The best is bromine. So I put bromine here, and they have a duo. This guy wins. Followed by carbon and hydrogen. So that's how we know that this fragment here, on this side, we will have the highest priority of 1, followed by the benzene ring, number 2, and the methyl group, number 3. And of course, with the H to the back is number 4. So now you want the number 4 group to point to the back, which is what is this right now. And you do a rotation of 1, 2, 3. What do you see? 1, 2, and 3, which is clockwise. So clockwise means this carbon here is R. Now for the next carbon here, again, the last bond is not being shown. It must be a hydrogen. That's of the lowest priority, number 4. So we have H, Br, carbon and carbon. These 2, we have to go further. Again, this is number 4, pointing to the back, very useful to us. This must be number 1, which is number 2 then. So carbon here connects to carbon, carbon, hydrogen. So I'll put down C, C, H. This way, this carbon connects to a carbon, carbon, hydrogen. See? Carbon, carbon, and a hydrogen. At this junction, again, we cannot decide the winner because they are the same. So we have to go one more. Now the question is, there are 2 paths. Where should I go? I can foresee that this path here, I have a big guy called chlorine. So I go for this side. Alright? So the next carbon here will connect to a chlorine, hydrogen, hydrogen. So Cl, H, and H. For the one at the top here, carbon connects to triple H that's rather small. I will go with the benzene ring. This carbon here connects to C, C, C. So now we take this group here and fight against that group. The best one here must be carbon. There's only carbon representing it, but here we have chlorine. So please do not add them together and say that, oh, this is bigger than that. You play the best card. Carbon versus Cl. Cl has a higher atomic number, the whole set will win. and hence this part below becomes the second highest priority. That means that side towards the benzene ring must be number 3. And now you remember this 1, 2, 3 is a clockwise rotation, and hence for this carbon here, it is also R. Let's focus on the last atom that's chiral in this molecule. Right. For this atom, again, lowest priority is your H, number 4. And the highest, we need to do a bit of work. Now over here, when we go one atom by atom, carbon, carbon, carbon is a draw. So you have to go further than that. And you notice that this carbon here has a ClHH. Cl is bigger than the other carbon, carbon H. Let me just write this for you. When you go up, this is CCH. Okay? When you go here, this is a CHH. So now you put this group together and you conclude that that side must be priority number 1, followed by this one, number 2 going up, and followed by that group, number 3. Why? Carbon against carbon, okay, draw. The next best card in this group is still a carbon. You put it out and you make it versus your H. Carbon is bigger, so this whole set will win. So now you see 1, 2, 3, it is R. So again, it happens that this is R, right? So I hope that you have learned how to determine R and S configuration of a chiral molecule.